In this short video, I'm going to be looking at nomenclature of organic molecules, the connection between the name of an organic molecule and its structure. And in my second of 5 slides, I'll be introducing you to a list of points that were agreed on internationally, through which we can name any organic molecule. I don't use the list per se. I don't go through the steps 1, 2, 3, 4, blah, blah. I use it instinctively. You get to do that with practice, as I hope you'll see. But for reference, here we are. So nomenclature is a set of rules agreed on internationally so that naming compounds is clear and followed by all. For organic molecules, we identify the longest chain of carbon atoms first. Secondly, we identify the main functional group that changes the properties of a molecule. A functional group could be an atom or a group of atoms. Thirdly, I'll identify any side chains. By that, we're looking at any other carbon atoms present in the molecule that are not part of the longest chain of carbon atoms. And then identify any other functional groups or side chains. If there's more than one, then we name alphabetically. Then number the carbon atoms in the chain so that functional groups and side chains can be located. And we number from the side that gives the lowest numbers. Small point, not very common. Class names are used when the functional group added to a molecule that is part of another homologous series. My example, 2-hydroxypropanoic acid. I look at a chain of 3 carbons. That's the first step, the longest chain, pro. I look at the main functional group, COOH, propanoic acid. Any side chains? There are none. Any other functional groups? Yes, the OH, the hydroxyl group. Now, what I'm going to do now is to number the carbon atoms. I'm stuck. I've got to start from the side that includes the COOH. That's a functional group and by its nature has to be at the end. More on that in just a second. But if I count from that side, I get to carbon 2. I've got the OH, 2-hydroxypropanoic acid. Why does the propanoic acid, why does the acid group have to be on the end? It's because it involves the carbon making 2 bonds to an oxygen and a 3rd bond to an OH. Only 1 bond to be made. It can only be at the end. The number of carbon atoms in a chain is given by a prefix, based on the parent alkane. When I'm naming, I often start, almost subconsciously, by thinking, what alkane are we basing this on? So when I name any organic molecule, that's how I'll start. Meth, 1 carbon, eth, 2, prop, 3, bute, pent, hex, 4, 5, 6. The positions of functional groups are indicated by numbers using the smallest numbers possible. If there's more than one functional group, they're named in alphabetical order. Some of the isomers of C5, H10, BRI. And I notice straight away I've got 2 functional groups. I will always name the bromo before iodo. Alphabetical order. First example. Bromine is on carbon 2, counting from the left. 2-bromo. Staying with counting from the left to be consistent. 2-bromo, 4-iodo, pentane. In the rest of the examples, I didn't put all the hydrogens in. We know where they are. Second, I'm again basing this on pentane, 5 carbons. Counting from the left again, 2-bromo, 1-iodo, pentane. Noting that I'm going by alphabetical order rather than naming what's on carbon 1 and carbon 2 and so on. Alphabetical order always. Next, doesn't matter which side I count from. 3-bromo, 3-iodo, pentane. And again, next row. Here, 1-bromo, counting from the right to give me the smallest numbers. 1-bromo, 3-iodo, pentane. Longest chain of 5 carbons again. Next, now I notice I've got a chain of 4 carbons. And I've got 3, let me call them substituents. 3 things added to that chain. Bromine, bromo first, iodine, iodo second, methyl third. Going from the right, 1-bromo, 4-iodo, 2-methyl, butane. And now my longest chain is 3, so based on propane. Again, 1-bromo, counting from the right, 3-iodo, 2,2-dimethyl propane. Few more. Pentane, my longest chain, 3-methylpentane. Now, based on pentene, and my double bond is at the end, so based on pent-1-ene. Counting from the right, 2-methylpent-1-ene. 2 double bonds, diene. 1,4, whichever end I come from, 1,4-diene. Pent again, pent, 1,4-diene. Carbon on number 2, 2-methylpent-1,4-diene. Again, longest chain of 5. Based on pent, double bond at the end, pent-1-ene. Staying with counting from the right, 4-methylpent-1-ene. Longest chain of 3. Double bond, propene. I have a methyl group on carbon 2. I could say 2-methylpropene, that wouldn't be wrong, but no need to have the 2 indicated. If my methyl group was at either end, I would have a chain of 4, not 3. Last. Based on pent, double bond, based on pentene, double bond at the end, based on pent-1-ene, and counting from that same end, 2,3-dimethyl. 2,3-dimethylpent-1-ene. 2 questions to end. What's the name of this molecule? Please don't look at what's in blue if you want to try it. My longest chain of carbons is 4. I'm ending in the acid group, so based on butanoic acid. Takes me to A or B. Numbering from the side where the carboxylic acid group is, the methyl group is on carbon 3. Takes me to A. Longest chain of carbon atoms is 4, based on butanoic acid. Side chain on carbon 3. Finally, got to be careful here. My longest chain is actually 4, though it wouldn't be at first sight. If I was in an exam, I'd be taking the blunt end of my pen or pencil, placing it on the paper. How many carbons can I go through without taking it from the paper? And it's 4. Doing it with my cursor here. 4 carbons, so based on but, I've got the acid group based on butanoic acid. Numbering from the side, the right, where we find the acid group, to methylbutanoic acid. That's it. If you found that useful, please hit like. Please subscribe to be informed about more content.